All right. Yeah. Well, he said I have until 8:30, and I was just counting my, looking at my watch, and the time was passing by, and I already prepared around 1 hour talk. But I guess since I don't want to keep you waited, I will probably talk a bit faster. And I will also show you a bunch of slides and some, references. Don't worry if you don't understand it right away, because I do not expect you to understand it right away. So you can get the slides and all those source codes, references, and everything. Take a look at it later at your time and your pace, so you learn everything about what we're talking. There's a bunch of things I go through which I hope you have never heard of it, at least. And there are also a bunch of references that they are quite new actually in Flutter world, to be honest. And hopefully you can take a look afterwards. Just a quick question. Have you ever ran to any kind of crashing an app by memory problem? It happened, right? So that's good, because that's the purpose of the talk. So even if you have not seen this type of error yet, potentially you have a memory leak right now. You don't just know it. And after seeing some of the examples, you probably see that you have some of those. It's just because probably your app is not used that much or something like that, maybe. Otherwise, your app would have crashed, and so far you know. But just a quick introduction. I was already introduced, but my name is Majid. I'm coming from Oslo. Surprisingly, I came from a temperature of 23 degrees and sunny to a coldness of 7. And I'm coming from North Pole, so I don't know what's happening. I was shocked when I actually get off the plane today morning. It's like, what's going on here? Like, it was summer where I was leaving. So, and apparently tomorrow is even worse here. So it's gonna be maybe 5 degrees and lots of rain.
That's not for the better.
Yeah, sure. So I have been doing Flutter for a long time together with Dominic, and I have written also a book last year published, and I'm recently working at Microsoft, nothing to do with Flutter. So I'm here just because I love Flutter. I'm still passionate about it. In my spare time, I do a lot of Flutter, and I am also a Flutter GDE or developer, Google developer expert for that. What you will see today is gonna be a quick overview on Dart VM. If you don't know how really it works, just a quick simplified version of it. I have some slides to show you, but then there are a bunch of talks referenced here, so you can go and watch to understand way deeper, if you wanna go deeper. Then we go through some best practices and what you can do to avoid some of these memory leaks, and when you understand how Dart VM works, you can technically use those techniques to ensure you're not having memory leak in your applications, and some tools that you probably need to spend some time to have a better knowledge around it if you don't know it. So first thing is that the memory leak may happen not necessarily, we know the layers of Dart, right? We know, Flutter. The thing I want to mention is that this memory leak may happen in every of these layers. Today, I'm not talking about like the native part and the other layers, just focusing on the very top part, the Flutter framework itself, the Dart codes, and where the Dart VM shines, okay? We're just talking about that. Let's just clarify this. Because if you are like today, Dominic was talking about the plugins and native code and so on. If you have such a problem in a native layer, a kind of layer code, so that's something that we're not going to talk about it today. But let's just also have a differentiation between memory bloating and memory leak, because these are two different things. Anyone knows what is memory bloating? Yeah, it's here, but what is it? Absolutely, that's correct. Yes, memory bloating happens when you are allocating memory when you need it. Like, for example, you load an image to memory, suddenly the usage of memory goes higher up, right? And it stays there because you still have that object in the memory. But memory leak is when the memory steadily, without you doing anything, just by using the application, steadily goes up and up, up and up until the app crashes because it lacks having enough memory. So these are two different things it's important to understand. We focus on this one, although I give you some tips for the other one as well. So this is a super, probably not readable diagram, especially if you are sitting all the way down. Doesn't matter, so I will go through it right now. But the point here is that from this slide, I want to mention that the Dart, if you don't know, so the term that we're saying, the Dart is a garbage collected language, which means that we as developers are having a kind of peace of mind in order to let the Dart VM to free up the memory for us. Well, that's good, right? That's a promise that Dart VM makes, but there is a but here. We're going to focus on that but right now. And I'll go through these steps, how this works. Essentially, the Dart VM garbage collection is named as a generational garbage collector, which means it has two different phases. One is, as we call it, nursery, or young space, or new generation. So what happens is that as soon as an object is created and it's not used, then it immediately gets garbage collected. And there is another one that's what we call it old generational phase. We'll get to both of these right now on a high level to understand what goes to the next phase and what goes to the first one and what you need to do. So let's start from here. Every object, so in actually this is kind of true in many all languages, every object lives in a memory, or this is called also heap, right? The memory is called heap. So it started from a root kind of object reference. So you have an object that is referenced and everything starts from there. So what happens is that Dart keeps track of these objects and reach the other ones as soon as they are, as long as they are reachable. So, and then if nothing then gets to a point that nothing is kind of detected, or there is no points to an object anymore, then the Dart garbage collection will take care of that object and just free up the memory by removing that from the memory. Okay. So, but essentially, if there is still a reference, you will see right now in this diagram, if the object, as I said, there's no reference, it goes to an algorithm called marked and sweep as well. So then it gets marked, and then garbage collection afterwards, whatever is marked, then it's going to go and free it up, sweep it away. But then if there's still a reference, so I'm actually focusing on the reference part of it for an object, it will still remain in the memory. So why this is important when I mention about reference multiple times, it's just because if you create objects that even if you think you have removed them, but still the Dart VM sees a reference from them, it cannot or it will not remove them from the memory. That's your responsibility to make it removed and free up the memory afterwards. Or the garbage collector will remove it and free up the memory. Okay, let's get to that. So that's very high level way that the Dart VMs in this case works. You have that root object, then all of these reference. If suddenly something is kinda not referenced anywhere, then Dart VM take care of that and will just swap it away. There is a very deep dive talk, around 45 minutes, by Anna, so that she has given this talk in Flutter Vikings 2-3 years ago, in Oslo actually. And I encourage you to scan this and take a look at that, because she goes through the implementation of garbage collection in Dart, and it actually she explains exactly how all of these steps that I mentioned works, line by line and step by step. Okay, so far then we understood. Then Dart VM or garbage collector will take care of whatever that is not referenced, which is very good. Then we're going to be happy, right? And as a matter of fact, this picture, by the way, is generated by GPT, I think, latest model. And I'm so surprised how good is the picture, because I just asked, can you give me happy Flutter developers who saw a garbage collection? And it gave me this one. I'm actually very surprised. It knew about the logo, and the typography was very good. And Dominic was saying, oh, don't make me use Copilot. I'm going to be replaced. No, you will be at some point. You're just not ready to accept it yet. So no, I'm just joking, of course. But there are some objects, that's the problem. There are some objects that what we call it memory risky objects, or disposable object. Can you name one disposable object in Flutter?
Controllers.
Absolutely, controllers. So these are the objects that even though you create them, you think that, well, the widget is all the way, like it's removed from the screens or everything is fine, and still they're gonna stay in the memory. So, and I'm gonna go through some of these memory risky objects right now, and you see how you can also fix them by referencing, so that Dart VM can take care of garbage collecting them. So one example would be this one. Can you recognize this code? It's a very simple 4 lines of code that you must have written at some point. Have you ever written this code before? Exactly like this. Anyone? You've never written Flutter code?
I never register handlers in the build method.
That's a good one. Keep that for yourself for now. What is the problem with this code? You probably written like that, right? You have some kind of higher kind of order function. You're passing your team of context to just apply something and then pass it to a register handler. No one.
The reference of the context.
Yeah, the problem is the context. The context object in this case in Flutter is supposed to be a short-lived object. When you pass that to a callback like this, after the widget is swapped away or removed from the screen, the reference to the context, because it's in the callback, cannot be removed, and therefore the context will not be garbage collected. So what happens is, this is like what happens. Essentially, you have this widget instantiated, and then you have some operation, then you dispose, and still because you have that closure, and passing that closure, the context, you probably have done that by passing your context to a service at some point later. Don't lie to me. Every developer who start in the beginning by Flutter do that. So this is quite kind of normal. So what happens then in this case, when the context is not garbage collected, what's the purpose of build context, by the way? Let's have some question. except Dominic. Anyone else?
Access data on inherited widget, yes.
Well, that's could be one of it, yes, but it's not exactly what I was looking for. What? Element. It creates, okay. Dominic, you want to say?
That was a very good answer. That's an element, essentially built context.
Exactly.
A disguised element of an element tree, which is a long-lived tree.
Absolutely. So what happens then if you have this context from the widget, build context, then passing to a closure, and Dart VM cannot take care of that, then it will when you go to this widget and come back multiple times, so then you are actually creating multiple of these contexts, still keeping the reference in the memory. So even though you are destroying or disposing your widgets. So if you look at then the memory in your Flutter DevTools at some point, you might notice this kind of like line that is happening. This is one of my applications. So when you look at this, see that slowly the usage of memory after using some of your pages, which has that kind of closure, goes higher up and up. And it's probably, this is deliberately noticeable, but it's not noticeable until you stay on the app for such a time, some time. So how can you fix this kind of problem? So we're talking about then passing objects that then they cannot, the Dart VM cannot recognize whether the reference is disposed or deleted or not. There's no reference for that yet. This is still, maybe it's not even reachable, right? So in this case, you just need to deliberately make it reachable by Dart VM. So here is an example. Instead of passing the context itself directly to the closure, if you just make a reference first, like define a final variable or something, and then pass that, then in this case, you're good to go. So think about this, this pattern and apply it to everything else that is supposed to be a short-lived, but you're passing to closure. You can make it Dart garbage collected object. Another kind of example is so variables or like global variables or static fields. So these are also part of long-lived classes that can prevent memory from being somehow swapped away or released. So what can you do in these cases? Let's have this array, for example, here as an example. I'll come back to this with a solution. So, or another way is like when you generate suddenly like a big list of, let's say, objects or list of numbers in this case with the list object. So these are holding the memory, and if you don't clean them up, they will stay there. So one of the solutions could be so that you create a limited size kind of class that handles these type of cache mechanism that you might have in your application, where you'd actually define a limit for your object. You also can remove whenever is necessary by just calling a method or something. So, but another way that you can just create those objects in order to make sure that Dart VM at any time can garbage collect those objects is using weak reference. Have you ever used weak reference before?
No.
Well, that's good. At least you learned today something. So the weak reference lets you keep actually a reference to an object without, and that is very actually important, without preventing the Dart VM to garbage collect it. There is a catch here though, because if you use weak reference, you always need to double check by target on that to make sure it has not been garbage collected. If you get a null from target, that means Dart VM has already removed that. And it's not, well, this is good and bad. You need to find your use cases. And I have a use case for this as well to show you quickly. If it goes to, yeah. Here's an example. So when you have, for example, an image for caching purposes, here's where you can probably define your cache as a weak reference. But a better example, which Dominic also mentioned about database, oh, no, sorry. Not database. So I'll get to database afterwards. But a database also could be one of them. So that I guess database, you don't want to do that because you want to keep the reference all the time to be able to interact with database. For database, I have a better way to do it, though. Bear with me. So another way is for the map kind of object that you create, instead of map, using the weak map, where in this case, first of all, the weak map can be imported from widget.dart from Flutter. So this is accessible without any package. Well, that is good. And this is for key-based storage, where the keys are held weakly, which means they can be garbage collected when there is no reference to this, or when the entry is removed, let's say. So here is an example. I put it here. I don't think is it readable at there and at the last line, last row. Yes, good. So imagine you have your keys, and now you are removing an entry from that key. Though in this case, Dart VM can automatically at some point, so garbage collected that key as well. So the next one I want to mention, which is this one is good for, especially if you are working with the kind of database or the native integration with Flutter. Let's get to that. The finalizer is where you can define a callback where you can register different cleanup after an object is not accessible anymore. Well, let's see what it means. So imagine now, this is how really it works in practice. Imagine now you're creating like some kind of object, and you want to clean that up after like the widget is disposed. But that object is already, you don't have access to that anymore. But how can you clean that up in that case? Like it's a native code, you need to call it, but you don't have access after dispose anymore. So in this case, you can register that callback for cleaning up that particular object after even your main, for example, widget is not available anymore. Here is an example. A good example actually is for managing the native memory. I hope you're not really like, if you are dealing with native memory, let's say, so you need to call, in this case, you need to call let's say a native method or whatever to free up your memory manually. So what happens is that for your native wrapper, you can register your finalizer, and sorry, you already registered your callback to free up the memory. You can actually attach this finalizer, this memory that you have it from, sorry, this object that you have from the native. And once you're disposing, then just detach your finalizer, where in this case is going to call that object that is not anymore available for you to call to free up the memory. Another example is the database connection that I mentioned. So you want to like clean up your database, and here is where you can register a callback to clean up, dispose your database, and then whenever you want, you attach that database object to the finalizer callback, and whenever you need it, just detach your finalizer to get to call the callback to clean up your connection. All right. Are you with me?
I think that's the same finalizer to many classes.
Many classes. Yes. All good?
Yeah.
I feel like everyone is super like, what's happening? Should I go to the next phase of the talk? Now I'm introducing disposable and streams and listenable, let's say, objects. So we're working with the streams in Flutter quite a lot, right? So we're assigning these streams, listen to them, and we know that quite often we are disposing these streams as well, right? Let's talk about them quickly. So first of all, make sure you're disposing and you're removing your listeners in the dispose method. That's one thing. But then another one is when you have a feature or some type of feature that is doing something periodically. And in this case, one of the good practices could be if you cancel them when it's not needed, in particular case here where you are disposing your widget. So that's one example. Another one, we talked about disposing. I think I'm not going to repeat that right now, but when you are adding your listener, let's say in the life cycle of widgets, like initializing, like widget up, the other life cycles. So first thing is make sure, I mentioned, remove your listeners, dispose, but the second one is, for example, in some life cycle, like did update widget, when you want to listen to the listener, make sure before you're doing that, adding a listener on that, you're removing your previous one. Because if you don't do that, the previous one still will be kept in the memory. So you're continuously adding that into the memory. So always make sure you're removing previous one and then add a new one. So next, a little bit of these are like very nitpicky stuff. You may not ever get to that, but there are sometimes there are ways that you can optimize usage of the memory. So in small scenarios may not be like really important, but in like big cases and the apps that are heavily using, for example, building text and using with text, it might actually be very important to optimize the memory. As an example, you can, here's an example that you can concatenate as strings. There are different ways to actually do that, like appending a data, in this case, to an array. So you have byte builder, add all, spread operations, concatenation, like plus, literally, and you can add up like to that list. But each of them comes with a different performance catch. So you need to make sure you use the correct one when it comes, because you're allocating less memory for your application. Here's an example for byte builder, just for concatenating some text. And we all know about context, sorry, not context, constructor. I guess everyone knows that. Anyone in this room who doesn't know about? You don't know about the okay, that's very good. Can someone explain to Dominic, because he's GDE as well, can someone explain to Dominic what is constructor? Like he is 5?
I am 5.
Yes. I am serious. Can anyone explain?
The object that doesn't change.
It's an object that doesn't change. That's very harsh. It could be softer. It's an object that can change.
Will we take it to GDE community?
Sorry?
Will this...
I mean, we are GDE, but we don't guarantee we know everything, right? So, yes. But that was correct, by the way.
Yeah, so this is the object that can have only one instance. Canonical.
Are you convinced? 2 good examples. You understood then? Yes, good. All right, so good for optimization. Let's move on. as much as possible, use the lazy, building the items lazily, like for example, using the list view builder can be a good thing to do. So this is just the best. I guess you all are doing this right now anyway, but just to bring it up and mention it right now. But one thing I want to mention right now is just about the mindset of us thinking about now memory leaks. How to prevent all of this then in our application. I think we need to start by thinking of detecting these issues as much as possible, bringing them back to the development so that we can figure it out. Like, as we call it, shifting left in software engineering, right? So the closer you get to where you start, where you write, and the sooner you get access to those problems that I mentioned, well, it's easier to fix and it's less costly to fix. So things like, for example, static analysis, you all use like Flutter lint rules probably, or some of you may use tools like DCM, or in testing like locally on your machine. Two tools that I want to mention, if you have not heard about them, maybe you start using them or at least experimenting with them. One of them is this one, Leak Tracker from Flutter and Dart team. Have you heard about it before? Yeah, that's good. This is still an experimental package. Some of, at least the packages underlying is experimental, including memory usage. I actually really like the memory usage package in this example. I have also an example for you to look at it, how it looks like when you use it. But the good thing is that when you start using this package, you can catch the memory leaks during your unit test and widget test that you write. So this is quite nice. Like, do you write test? That's the first question in play. No. So then you don't need to use this. But if you write test, you can use this and leverage your test to catch the memory leaks ahead of time. That's one thing. So then another one is, here's an example, by the way. Again, this was an experimental. This is from the package. Just an example to let you know how it works. So the memory usage tracking package for me was very interesting because it was automatically, oh yeah, it's coming. It doesn't show here. This was very interesting for me because when you use the package, so it automatically takes snapshots, and then you can use the snapshots to detect the memory leaks in your application. That was quite interesting for me. This is happening quite fascinating, to be honest. You start using your application, and the package is taking the snapshots when it's necessary. So, and well, then you can open up your, let's say, DevTools and take a look at like the snapshots and then figure out what really is causing any kind of problem. Well, this is interesting and this is nice. And one more thing I want to say is please, 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 Flutter DevTools is quite advanced. It has a lot of features, especially for memory and profiling. Really, if you have not deep dive into learning the memory preview or the panel of the Flutter DevTools, take your time and go through it one more time and figure out all the details there. Why this is this color, why that is that color, and so on. And then figure out and learn it in depth, because it gives you a good indication of your application when it comes to memory leak and when you need to optimize. And lastly, I want to mention about DCM. DCM is a tool which is built on top of, or in addition to the Flutter lint rule that you use, lots of rules that you have. DCM comes on top of that. It has the Dart Analyzer package, very optimized built into it. And it comes with different features, such as metrics, rules, and so on. And there are multiple things that you can use from DCM. By the way, you can use the free version of it, and it's still gonna be good for memory leaks. You have lots of rules for enabling to catch those problems that I mentioned as a rule to detect them ahead of when you are developing. The recent addition to DCM was this dashboard where you can analyze you can upload a list of problems to the dashboard and visualize it. And it gives you also indication of, oh, for example, you have a couple of memory leaks which you might not have detected yet. But the DCM can help you to realize that by uploading your project's metadata. A couple of rules here, for example, for removing the listeners. That's one thing. So disposing the fields or classes that has explicitly dispose method. So you can have rules, you can even customize them. So there might be some classes that you don't want to necessarily dispose. You can even customize and say, hey, I don't want to just dispose, for example, line press, gesture, recognizer, or whatever. Just give it some customization. And streams, if they are not assigned, is not a good sign because that means you're not disposing them, you're not removing the listeners. So just unassigned streams are not necessarily a good thing, so you need to take care of them. There is like, as you see, there's a rule for that you can detect. And even the optimization tips that I mentioned, like with prefer byte builder, you can have those kind of rules to just hint you whenever it's necessary to refactor part of your application to have a better reference. I think that was it. I kind of nailed it. It's 8:20 in 40 minutes. And so this is the slides, just in case if you want to go through the examples. I know I talk a bit fast. I didn't go very in detail because each of these require actually a lot of explanation. I encourage you to take the slides and go through each of these slides, take a look at them again, research a bit. There are some notes for you as well, and hopefully that will help to avoid some memory leaks in your applications. And I also need to, yeah, that's actually it. Last slide. I had another slide, for some reason it doesn't come up. Two things maybe I show you before we go. Let me. Is it joking? Okay. No, it doesn't work. That was. I have a very in-depth article written in this blog as well, if you want to read about memory leak. Not everything that I said today is written there, but at least you're gonna have a very long kind of detail of some part of the talk. And just a sneak peek of the dashboard of DCM that I showed you, so you can create different projects. And every project that you have, when you upload this metadata, you can actually see an aggregated data of all of your project within your organization. Like you have 10 packages, 2 projects, 2 apps, and so on. You can upload them differently. You can have different views. So you can also see like an overview of the entire organization problem. So it's to tell you, for example, in organization, I have 6 memory leaks somewhere. And then also you can have historic data, like you can take a look, what was your kind of problem? Have you had any kind of improvement? At some point you had suddenly fixed a lot of problems in your organizations and so on. It's not just about memory leaks, it's about actually any type of issue. And lots of other metrics for code quality. So there's a lot of metrics. I'm not gonna go through that, just wanted to give you a quick overview. Each of the project can also have their own view. You can see the issues, you can see the violations, and so on and so forth. Just wanted to show that very quickly. And last one, maybe if you want to, I don't know why it's not here. Leak Tracker, Flutter, there you go. this page, please take a screenshot if you don't know. It's under Dart Lang Leak Tracker repository, and everything is there. They're actively working on that, so this is good, and you can take a look at this package and start using that. Usage is so simple that I did not bother to even add to slides. It's so simple. It's just one line or 2 lines. That's it. So it's nice to experiment with that. That's it. No, I think it's just profile. I've seen it, it's just profile, yes. But it would be very nice if it worked in release, right? Yes, right? You know, there is a tab here, it says issues.
Oh, really?
Yes.
Tell me about it.
If you like, you can even with Copilot write about it. I have to mention it. I work for Microsoft, man. I need salary at the end of the month. All right, so I'm joking, of course. Any question? I don't take question usually, by the way. But no pressure. Any question? Yes, please. You usually ask very hard questions, I notice.
Yeah, okay. Thank you for this also good talk. And my question is, does DevTools allow to identify if it's memory leak in native layer? So, no?
No, native layer is your responsibility if you are doing that, though, by the way. So, but Dart garbage collector only works in the Dart layer. That's it.
So how I can identify?
Oh, you mean for native? How you can debug for native?
Yeah,
that was
how
the question.
if it's memory leak in some plugin.
Android Studio has a memory tracker, and Xcode has an amazing.
For Android, you can.
Yeah, for each of. Exactly.
Okay, thank you.
I have so many fans to answer.
I have a question. I don't know if that's okay. So yeah, so I would like to know if it seems that the garbage collector of Dart is similar to Java at the end, right? Or it has their differences?
Well, no, it has differences. First of all, I don't know Java exactly like how it works, to be honest.
Very similar, like.
But I can imagine it can be similar because both of like very kind of comes from same.
Yeah, because at the end, some languages, it's like it's your responsibility to say to the garbage collector what they need to dispose, you know. But in Java, it's like automatic. So Dart at the end.
Java is also the same here in this. I mean, correct me wrong, Dominic, if I say something.
So the serial parallel generational and the
Java.
yeah.
Yeah, Java has 4.
It's much more complex.
I actually don't know much about Java in detail about at least the garbage collector in Java, but I can imagine because while there are different algorithms, but on a very high level, how these kind of things works is usually by a reference. Like they go deep and figure out if there is something somewhere that there is nothing attached to it, so that in this case they're gonna remove it, right? I can imagine it could be similar in both, but different implementation, obviously.
Okay. Just wanted to know if you
yes.
know a little, but it seems it's very similar, yeah.
Even in Java, I guess you need to make sure that if you have a memory risky kind of object, you're still taking care of that.
Yeah.
So,
thank you.
No problem. So, we have no more question. One more question.
Hey.
Hi.
Thanks for the presentation. So you have showing a slide with cancelable operation. That's a thing. So my question is, if I'm not mistaken, the cancelable operation after canceling actually will still execute the logic, but it won't return it. It will not complete the future.
No. Because you're canceling the interval, it doesn't.
Yeah, because from what I knew is that Dart doesn't have such a mechanism to drop from event loop that future, but it can work with, for example, isolate. We can close the isolate.
But let's well, we can search right now, but logically think about it. We have a feature that has an interval inside that's something happening like every second, let's say. Now I cancel it. Do you say that that seconds continues forever? I'm not going to use Dart if that's the case.
I mean, yeah. I believe
I don't think so.
The body of this cancelable feature will still be executed, but it will not return the it will not complete the future, so that if there was some callback, it will not be executed.
I can imagine Dart has this event loop, right? So every time something happens, it's scheduled, it like goes to the loop and so on. So I can imagine then, even if that's the case, that means that callback, like whatever it is in that cancelable feature, is not going to even loop at least. So your thread, like the thread that has the memory, sorry, not memory, the event loop is not taking care of that. So probably it's the case. I actually don't know. This is a good question. Maybe we should search about it. Should I ask ChatGPT? Just to make Dominic happy? Cancelable feature in Flutter. I don't think actually that is...
The feature will execute until the end. You will just
you will not get the result only, but does it go to the event loop as well, like that?
run like all the way.
All the time?
I mean, you cannot prevent this from executing.
Okay.
That's a known thing. Like even if you have a cancelable feature in Dart, it's not really cancelable in this meaning that it will not execute. So let's say you have a long-running task that saves something to the disk. If you have a cancelable feature and you cancel that, unless it crashes, it will go to the end and save it to the disk.
Okay, so that means if I have...
Fake cancelable feature.
Yeah.
Test it on the Dart dev.
Test it at what?
On Dart dev.
And that's fun, yeah.
Yeah, we can test it on Dart, but why not? Do we have time?
I don't think we have time.
Let's see if we can crash Dartpad. I mean, if we can, we can.
I think you can use Gemini in that one.
Oh, can we? Actually, we can. All right, so can you... Sorry, Dominic. Create a cancelable... Cancelable...
That's the hardest part of it.
Future. Yes. Cancelable future and cancel it and show me how it works. Okay, so that's a cancelable and that's then and that's delayed and that's okay. That's a lot of implementation. Then cancel. It actually implemented, yes, you're right. But what should I ask? Help me. Should I, let's just accept, see what, wow, it doesn't even work.
Maybe your example from presentation.
Yes, that's a good, where's my presentation? Memory leak, there we go. Cancelable.
There is a great, maybe not talk, but panel with the Dart team from FlutterCon. And this question, I think, has been raised, and Slava Yuganov, the maintainer of Dart, has been on screen.
Okay, that's good. Do you know which talk it, where? Last year FlutterCon. Yeah, okay. We can search for that and I will show you. So that's actually nice to know. I did not know this. Let's actually yes. Yep. Oh, because I don't think this I can work. Okay, let's see. Yeah, let's.
There is typo in the first line. Yes.
Yes. But don't worry, I have Gemini. Can you fix this? Well, wipe coding. That's the thing. See, it worked. So, okay, so it's canceling this delay task here and C. But what do we want to test even?
That's completed.
Well,
You want another button that cancels that. So like you press start and you press cancel and you still stay.
yes.
So how about the implementation?
We need to also have a cancel operation.
Check before execution if you cancel. So you can see how it works. If the late task is cancelled, so you essentially need to check if it has been cancelled.
Yes. Yes.
So this is a proof.
Yes, correct. Actually, yes. Now that's a good. Okay, let me just accept this blindly. But yes, yes. We need to read code and documentation and write test. That's the three skills.
Cancel operation is just a metadata definition. It's like a inverse of a computer.
Exactly. This is a good point. Yes. Back to your then concern. You are right. But at least what you can do, you can have this line, which I copy right now to my slides, and put it here before the feature, like here.
But this line will only prevent us from execution, not from adding to.
Not
from keeping.
It will not. Yeah, it will not. But at least it doesn't execute like.
You would have a for loop. You would have to in every iteration.
Yes, yeah, for sure. It's like a practice from the Java threads. So you are not able to
Yes.
the thread and.
But this is very good. Let's just keep this. I'll fix this later for my reference. But yes, this is actually very good. I like it. Thank you very much. And actually, we have cancel operation, by the way, as well. Like if I say this.
It says that you are unable to cancel operation.
I mean, we could spend 5 minutes to fix it, but I spent 30 minutes to write code with Gemini. But yes, we learned quite a lot of things. Thank you very much. I actually, to be honest, didn't know that. Surprisingly. See?
It's a fallacy, Dart. You cannot cancel that.
Because my imagination was like logically, I was thinking we're canceling, so then every execution, because it doesn't even go to the loop, then nothing will gonna be executed.
Do it like that when you have a control over the microtask queues.
Yeah, microtask. That's a good point as well. I need to spend a bit more time in that slide to fix it for you for some solutions. Well, very good, very good, very good question. Thank you very much.
Thank you.
At least we proved that Gemini also works in that path.